Beneath our feet, the ground is older than we can truly imagine. Each layer of rock is a page in Earth's story, and most of those pages were written long before the first human ever walked here. But what if, hidden deep in that story, there were entire chapters, whole civilizations, that came and went long before us? Imagine ancient cities swallowed not just by sand or jungle, but by millions of years. Towers worn down to dust, oceans shifting their shorelines, mountains rising where valleys once lay until no trace remains. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here, and tell me in the comments where you are and what time it is right now. I always find it fascinating to see our little community scattered across the globe. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. We begin with a thought that can feel almost unsettling. Our own civilization, our cities, roads, satellites, might not be the first intelligent society to arise on Earth. And if we weren't, would we even be able to tell? This is the heart of the Silurian hypothesis, a scientific question with a name borrowed from science fiction. It asks quite simply, if an advanced civilization had existed on Earth millions of years ago, would any of its evidence survive for us to find today? At first, you might think the answer is obvious. Surely there would be ruins, tools, maybe even skeletons. But here's the thing, nature is astonishingly good at cleaning up after us. Concrete crumbles, metals corrode, plastics break down under UV light and heat. Given enough time, even mountains vanish under erosion. Our proud skyscrapers and monuments, if left untended, would disappear faster than you think. And millions of years? That's not just enough time to bury a city. It's enough time to grind continents, recycle their crust into magma, and erase everything they ever held. Think about the vastness of Earth's history. The dinosaurs died out 66 million years ago. Yet if you didn't know where to look, you'd never guess they'd existed at all. Less than 1% of all life that ever lived has left any trace in the fossil record. Most of it vanished without a whisper. Even the fossils we do find are tiny fragments, preserved under rare and lucky conditions. If a species didn't last long or wasn't widespread, the odds of it leaving an identifiable fossil are vanishingly small. Now picture a civilization that rose in a warm, forested corner of the world 200 million years ago. Perhaps it mastered agriculture, built cities, developed machines. It thrived for thousands of years, and then disaster struck. A supervolcano, a sudden climate shift, an asteroid impact. Whatever it was, it ended them. Their roads cracked, their buildings toppled, the forests grew back. Ice ages came and went. Plate tectonics carried their land into the deep, molten mantle. And so, after millions of years, what would be left for us to find? Maybe nothing. Maybe a faint layer of unusual minerals in the rock, a subtle shift in carbon isotopes, or a mysterious warming period in the geologic record. Clues so faint that we might mistake them for natural changes. That's the chilling beauty of the Silurian hypothesis. It makes us realize how fragile the evidence of existence can be when measured against deep time. When you walk through a modern city, New York, Lagos, Tokyo, it feels eternal. The sheer scale of it makes you believe it will last forever, but our roads will crack. Our glass will shatter. Our steel will rust. And in 10,000 years, nature will have taken back nearly everything. In a million years, nothing recognizable will remain. In 10 million, the continents will have shifted so much that our home cities may not even exist in their present form. And if all of this is true for us, then it must have been true for any who came before. Maybe that's the quiet truth under our feet, that we're not the first, and we won't be the last. And yet, the Earth keeps the deepest of its secrets well hidden. To find them, we must go beyond obvious ruins or artifacts. We must learn to read the rocks themselves, because if the story exists at all, it will be written there, in layers that took millions of years to form. In the next part of our journey, we'll explore exactly what the Silurian hypothesis says, and why serious scientists are entertaining a question that sounds like pure science fiction. The Silurian hypothesis sounds like something pulled straight from a late-night science fiction novel, yet it's a real framework considered by actual scientists. The name itself comes from a cheeky reference to a classic Doctor Who storyline in which reptilian beings, dubbed Silurians, were said to have ruled the Earth in prehistoric times, long before humans. But the modern use of the term isn't about lizard people or pulp adventures. It's about a sobering, methodical question. If there was a civilization on Earth millions of years ago, how would we know? Two researchers, Gavin Schmidt from NASA's Goddard Institute for Space Studies and Adam Frank from the University of Rochester, published a paper in 2018 exploring this very problem. Their thought experiment wasn't meant to prove that ancient civilizations existed, but to see if we could even detect one if it had. This isn't idle speculation. They wanted to understand the limits of our geologic record, and perhaps more importantly, how future civilizations might, or might not, find traces of us. When we talk about a civilization in this context, we mean something with industry, agriculture, large-scale infrastructure. Basically, a society that could change the environment in measurable ways. Our own industrial activity leaves behind obvious markers: plastics in the oceans, radioactive isotopes from nuclear testing, concrete, metal alloys, and a rising blanket of greenhouse gases in the atmosphere. These are signals, but they are signals that, over millions of years, may vanish or become unrecognizable. The hypothesis asks us to think like detectives searching for evidence after an impossible amount of time has passed. Imagine walking into a room where someone had been sitting, but they left a million years ago. Dust storms have swept through, the furniture rotted away, the walls collapsed. How would you even know they were there? That's the challenge of detecting a deep-time civilization. Schmidt and Frank argued that the most likely signs wouldn't be artifacts like pottery or bones. They'd be changes in the chemistry of the planet. For example, our burning of fossil fuels releases carbon with a very specific isotopic fingerprint, different from the carbon naturally found in the atmosphere. If an earlier civilization had burned massive amounts of fossil fuels, they too would have left such a signal, perhaps recorded in sediment layers or ice cores. But here's the tricky part. Many natural events can produce similar signals. A sudden burst of volcanic activity, for instance, can change carbon isotope ratios in ways that might look like industrial activity. Global warming episodes have happened before, long before humans, caused entirely by natural processes. So even if we found such a signal, proving it came from intelligent life, and not just from a restless planet, would be extremely difficult. The Silurian hypothesis also forces us to confront a humbling reality. Our own time here is geologically tiny. Humanity's industrial period is barely 2 centuries old. If we vanish tomorrow, our major environmental signatures might be detectable for a few 100,000 years, perhaps 1 million in the best cases, before plate tectonics and erosion erase them. On a planet that's 4.5 billion years old, that's like a single frame in an impossibly long movie. The odds of someone, millions of years in the future, catching our frame are already slim. This is why the idea isn't dismissed outright by scientists. The Earth's deep past is filled with mysteries, unexplained climate swings, sudden extinction events, unusual chemical layers in rocks. Most, if not all, can be explained by natural causes. But what if, hidden in that noise, there's a faint whisper from something artificial, something not of volcanoes or meteor strikes, but of minds and hands that shaped the planet before us? It's not about rewriting history books. It's about knowing what questions to ask and what evidence to look for. Because if we learn to detect civilizations separated from us by millions of years on Earth, we'll be better equipped to search for them on other planets, where the timescales are just as vast and the clues just as subtle. In the next section, we'll go deeper into one of the hypothesis's most sobering implications, that even the most advanced civilizations might vanish without leaving a trace, erased by the relentless geology of our world. To understand why ancient civilizations, if they existed, might leave no trace, we have to talk about one of Earth's most patient and powerful forces, geologic erasure. Our planet is not a static museum where every artifact is lovingly preserved in place. It is more like a restless artist, constantly repainting its own canvas, layering new scenes over the old until the originals are hidden forever. The key culprits are plate tectonics, erosion, and the slow, relentless grind of deep time. Imagine a continent-sized conveyor belt under your feet. That's plate tectonics. The Earth's crust isn't one solid piece. It's broken into giant plates that move at roughly the speed your fingernails grow. It doesn't sound like much, but given millions of years, these plates can carry entire landmasses into collision with others, push up new mountains, and, most devastatingly for archaeology, drag the surface down into the mantle, recycling it entirely. If a city once stood where the Himalayas now rise, the stones that made its walls would have been ground into dust long before the first humans saw them. Even the tallest skyscrapers wouldn't survive being subducted into molten rock. Over enough time, every inch of Earth's surface is remade. That's why no ocean crust older than about 200 million years exists. It has all been swallowed back into the planet. And 200 million years is only a blink compared to the Earth's total age. Erosion is just as merciless. Water, wind, and ice don't just wear down mountains. They erase the sharp edges of everything. Concrete crumbles, metal rusts, glass shatters. Given 10,000 years, even steel bridges would be piles of oxidized rubble. Given 1,000,000, there might be nothing left but faint mineral traces. Add to this the freeze-thaw cycles, the grinding of glaciers, and the shifting of river channels, and you begin to see why deep-time archaeology is such a challenge. Then there's sedimentation, the slow burial of surfaces under layers of mud, sand, and dust. On one hand, burial can preserve certain materials, like fossils, for millions of years. But it also hides them so deeply that they become inaccessible without drilling or mining. And over very long timescales, buried material can be compressed and transformed into entirely new types of rock, erasing its original form and structure. Our own history gives us sobering examples of how quickly nature reclaims what we build. Consider Pripyat, the abandoned city near Chernobyl. In less than 4 decades, trees have cracked open asphalt roads, vines have climbed through the windows of apartment blocks, and wildlife has returned in force. Or look at the ancient city of Ubar in the Arabian desert, buried by shifting sands, forgotten for centuries until modern satellite imagery helped rediscover it. Those examples are measured in decades and centuries. Now multiply that process across millions of years, with continents moving and climates shifting. The difference is staggering. The truth is that the durability of any human-made object depends heavily on where it sits in the geologic landscape. A gold coin might last for millions of years if it's buried in the right sediment, but an entire city made of steel and concrete might be erased without a trace if it lies in the path of glaciers or on an active tectonic plate. And remember, most of our largest cities today are built near coastlines, on soft sediments that shift with sea level and storms. Those are some of the least stable places for long-term preservation. If an ancient civilization built its wonders in similar places, the odds of those structures surviving tens or hundreds of millions of years are vanishingly small. Instead of intact ruins, we'd be left with chemical clues, trace elements, odd mineral deposits, perhaps the ghost of a manufactured isotope locked in stone. But to even notice such a thing, we'd have to be looking very closely and with the right questions in mind. The Silurian hypothesis challenges us to think about time differently, not just in centuries or millennia, but in epochs and eras. To us, the pyramids are ancient, but to Earth's crust, they are newborn. The planet's slow, grinding cycles don't care about civilizations. They bury them, crush them, melt them down, and remake the surface anew. In the next section, we'll step back and see where our short human story fits into Earth's enormous timeline, and why that perspective makes the idea of forgotten civilizations both possible and almost impossible to prove. to truly grasp the scale of what we're dealing with, we need to place our own existence on Earth's full timeline. And here's the tricky part. It's not a comfortable perspective. If Earth's 4.5 billion year history were compressed into a single 24-hour day, humans wouldn't show up until the last few seconds before midnight. All of human civilization, agriculture, writing, cities, space travel would fit into less than the blink of an eye. This isn't just humbling, it's also a reminder of how little of the planet's story we can actually see. Most of that 24-hour day passed without us, without our ancestors, without even mammals for much of it. Entire continents rose and sank. Vast inland seas came and went. Climate shifted from global ice ages to hothouse conditions. And during all of this, life evolved, flourished, and vanished in waves. The fossil record, the main window we have into deep time, is patchy at best. Paleontologists estimate that less than 0.1% of all species that ever lived are preserved as fossils, and that's only because the conditions had to be perfect for fossilization to occur. Soft-bodied organisms almost never make it. Entire ecosystems can vanish without leaving a trace. If we have trouble reconstructing the life of a shallow sea from 100 million years ago, how much harder would it be to reconstruct a technological civilization from the same period, especially if it was rare, short-lived, and unlucky in where it left its remains? Consider this. The dinosaurs ruled the Earth for about 165 million years. They left behind countless bones, tracks, and other evidence. Yet for all that, we are still piecing together what they looked like, how they behaved, and how they evolved. Now imagine a civilization that lasted only 200,000 years, or even just 10,000 years, tucked somewhere in the past. In geologic terms, that's less than a blip. If dinosaurs, who reigned for over 100 million years, are still partially a mystery to us, a short-lived civilization could vanish almost entirely. And there's another problem: preservation bias. The environments best for fossilization, river deltas, lake beds, and certain seabeds, aren't necessarily where civilizations like to build. Most human cities today are built on floodplains, coasts, or areas of fertile soil, all of which are prone to erosion, flooding, and tectonic disruption. Even in the best-case scenario, evidence might be scattered, degraded, or buried beyond reach. The truth is, when we look into Earth's deep past, we are staring through a tiny fogged window with whole eras hidden behind curtains of missing rock and erased landscapes. Scientists call these unconformities in the geologic record, places where millions of years are simply gone. Rock layers that should be there aren't. They've been stripped away by erosion or never formed at all. If a civilization lived during one of those missing chapters, we might never know unless they left behind something that could survive the planet's recycling system. And yet, when we zoom out to this deep time perspective, something curious happens. The idea of a lost civilization stops feeling far-fetched and starts feeling like an open question. If the conditions for preservation are so rare, and if the timeline is so vast, perhaps the real surprise is not that we haven't found anything, but that we've found as much as we have. In the next section, we'll explore the strange, indirect traces that an advanced civilization, past or present, might leave behind. These won't be stone ruins or gold artifacts, but subtle fingerprints etched into the planet itself. If we ever hope to detect a civilization lost to time, these might be the only clues we get. If a civilization vanishes, leaving no monuments or machines, could we still detect it? The answer lies in something scientists call technosignatures. These are measurable effects or chemical traces in a planet's atmosphere, geology, or biology that might indicate advanced activity, even if the civilization itself is long gone. Here's where things get intriguing. Earth's rocks, ice, and sediment layers are like an enormous library, and each layer contains pages of environmental history. The width of tree rings can reveal drought years. Layers of ash can tell of volcanic eruptions. Even microscopic pollen grains can say what kinds of plants were growing in a region millions of years ago. If an advanced civilization ever existed, some of its actions could have left chemical fingerprints in these records. Changes so unnatural that they stand out from the background of normal planetary processes. Take, for example, industrial chemicals. Some compounds, like certain chlorofluorocarbons, CFCs, are entirely synthetic. They do not occur naturally on Earth at all. Modern human industry created them in the 20th century, and they persist in the atmosphere for tens of thousands of years. If a previous civilization had manufactured such chemicals, traces could remain trapped in ancient ice layers or locked in sediments. But chemical markers aren't the only clues. Large-scale agriculture, deforestation, or mining could also leave behind telltale signs. If a civilization cleared vast areas of land for farming, pollen records might suddenly shift from diverse forests to monocultures. Similarly, intense mining could concentrate certain metals, like rare earth elements, in unnatural patterns. Today, human mining has already moved enough rock and sediment to potentially create a geologic horizon that future scientists might notice millions of years from now. Then there's the possibility of radiological signatures, traces of nuclear technology. Certain isotopes, like plutonium-244, do not occur naturally on Earth in significant quantities today, but they can remain in detectable amounts for tens of millions of years. If a past civilization ever engaged in nuclear activity, deliberate or accidental, it might have left behind a radioactive layer in the geologic record, just as humans have already done since the mid-20th century. Of course, there's a catch. Natural processes can mimic some of these signals. Volcanic eruptions can release metals. Meteor impacts can scatter unusual isotopes. Climate shifts can cause sudden vegetation changes without any civilization being involved. This means that even if we did find something unusual, we'd need extraordinary evidence to prove it wasn't a natural event. That's why scientists searching for ancient technosignatures focus on combinations of clues. One strange chemical spike might be explained away, but multiple, overlapping markers, say an industrial chemical plus an isotope anomaly plus a sudden extinction, would be far harder to dismiss as coincidence. And yet, here's the most humbling thought. Earth's crust is constantly recycling itself. Plate tectonics drags entire continents back into the mantle over hundreds of millions of years. The ocean floor, for example, is never older than about 200 million years because it's continuously renewed. This means that even the strongest technosignatures could eventually be erased. The deeper in time we look, the more we have to accept that entire civilizations, if they existed, might be gone without a single trace. Still, the possibility remains. Perhaps one day we'll drill into a rock layer and find an unmistakable chemical fingerprint, a strange chapter in Earth's story that hints at intelligent hands. Or perhaps the record will remain stubbornly silent, leaving the question hanging forever at the edge of imagination. In the next section, we'll explore how these ideas connect to an even stranger mystery. Why, in a galaxy filled with planets and billions of years of history, we haven't yet found anyone else at all. The mystery of missing civilizations leads us directly into one of science's most unsettling puzzles: the Fermi paradox. It's named after physicist Enrico Fermi, who, during a casual lunch in 1950, supposedly asked, "Where is everybody?" On paper, the math suggests the galaxy should be bustling with intelligent life. The Milky Way has about 400 billion stars, and many of those stars have planets. Modern telescope surveys, like NASA's Kepler mission, have shown that rocky, Earth-sized worlds in habitable zones are common. If even a small fraction of these planets developed life, and an even smaller fraction developed intelligence, there should be, statistically speaking, thousands or even millions of civilizations out there. And yet, silence. No radio signals, no alien spacecraft, no obvious megastructures blotting out starlight, not a whisper from across the cosmic ocean. So, what gives? Why does the galaxy seem so empty when logic says it should be full? Scientists have proposed dozens of explanations, each more thought-provoking than the last. One idea is the Great Filter. Think of it as a nearly insurmountable barrier in the path of life's development. Somewhere between the formation of planets and the rise of galaxy-spanning civilizations, there might be one or more incredibly unlikely steps. Maybe life itself is rare, or maybe microbial life is common, but evolving to complex, intelligent beings is almost impossible. Or perhaps intelligence arises often, but civilizations tend to destroy themselves before they can reach the stars. If the Great Filter lies behind us, then we're incredibly lucky. It means Earth already passed the nearly impossible hurdle, perhaps in the leap from simple cells to complex ones. If it lies ahead, then humanity might be on a collision course with it, perhaps in the form of self-inflicted catastrophe, environmental collapse, or runaway technology. Another possibility is that civilizations are out there, but we can't detect them. They might use communication methods beyond our comprehension. Laser pulses, quantum entanglement, or something stranger. Or they might deliberately stay silent, following a cosmic version of the dark forest hypothesis. This chilling idea suggests that the universe is like a dark, dangerous forest, where every civilization hides to avoid predators. Broadcasting your presence could be a fatal mistake. Then there's the thought that civilizations may burn brightly but briefly. In cosmic terms, 1,000 years is a blink of an eye. If technological societies tend to collapse or transform quickly, the odds of two existing at the same time, and within range to communicate, become vanishingly small. Finally, some scientists entertain a more humbling possibility. Maybe we're just not that interesting. A civilization millions of years ahead of us might see us the way we see ants, worth a passing glance, but not worth building a bridge for. Or maybe they've already visited in the distant past, and their traces have been erased by time, just like any ancient Earth civilization might have been. This brings us full circle to our earlier question. If intelligent life could rise and fall without leaving an obvious trace, maybe the universe isn't empty. Maybe it's filled with ghosts of civilizations. Their monuments crumbled, their signals faded into the cosmic background. The silence might not mean we're alone. It might mean we're latecomers to a galaxy that has already seen countless empires rise and fall. In the next section, we'll look at what these possibilities mean for the future of humanity, and whether our own civilization could leave a mark that endures for millions of years, or if we too will fade into geological whispers. If the galaxy has indeed hosted civilizations before us, then the question becomes personal. What will happen to ours? It's not enough to wonder whether intelligent life exists somewhere out there. We also need to ask whether we will last long enough to matter. This is where studying the possible lifespans of civilizations becomes more than just science fiction. It's a way of holding up a mirror to our own species. Let's start with the sobering truth. Earth itself is not permanent. The sun, our life giver, will eventually swell into a red giant and boil away our oceans. But that's billions of years away. Our real threats are far more immediate, or more. History already gives us warning signs. The Roman Empire lasted about 500 years before political instability, economic collapse, and outside pressures brought it down. Other civilizations, like the Maya or the ancient city of Mohenjo-daro, also rose to impressive heights before vanishing into the shadows of history. But here's the difference. Those collapses were regional. Humanity today is a global civilization. We're interconnected like never before. That's both a strength, because we can share knowledge instantly, and a weakness, because one disaster could ripple worldwide in days. The possible endings for a civilization like ours fall into a few broad categories. 1. Self-inflicted collapse, war, environmental destruction, or runaway technology could undo us. In the nuclear age, we've already seen how close a single misstep could bring disaster. In the digital age, we're facing new risks, from AI gone wrong to cyber disruptions on a planetary scale. 2. Natural catastrophes. Asteroid impacts, supervolcanoes, or massive solar flares could reshape the world. We've seen the damage an asteroid did to the dinosaurs. Humanity would fare no better without preparation. 3. Slow decline. Civilizations might not fall with a bang, but with a whisper. Economic stagnation, resource depletion, and cultural fragmentation could slowly erode our ability to innovate or cooperate, leaving future generations in a more primitive state. 4. Transformation, not extinction. Some civilizations might disappear, not because they died, but because they evolved beyond recognition. Imagine a future where humans merge with machines, live in virtual realities, or spread so widely through the galaxy that the original Earth-based society no longer exists in any meaningful way. But there's also an optimistic scenario, the one we like to believe in when we dream of a Star Trek-style future. We survive, adapt, and spread into space. We build habitats in orbit, colonies on Mars, and mining stations in the asteroid belt. We learn to harness fusion power, repair ecosystems, and manage risks before they become existential threats. In that version of events, humanity might last not just thousands, but millions of years. If we could achieve that, we might solve part of the Fermi paradox ourselves, not by finding others, but by becoming the civilization that endures. Imagine Earth in 1 billion years. The continents have shifted, the oceans look different, but orbiting the sun is a gleaming network of space stations, all maintained by the descendants of humans who refuse to fade away. That future won't happen by accident. It would require us to think on timescales far longer than any election cycle, company lifespan, or even personal lifetime. It would require the kind of long-term planning ancient civilizations didn't always manage, because while they could build monuments to last thousands of years, they rarely planned their societies with the same endurance in mind. And perhaps that's where our story ties back to the ghosts of the past. Every collapsed civilization we uncover on Earth is a reminder of how fragile greatness can be. Whether they built step pyramids in Mesoamerica, carved statues on Easter Island, or engineered vast irrigation systems in Mesopotamia, they all thought their achievements would last. In the end, time proved them wrong, unless, of course, we learn from them. In the next section, we'll explore whether humanity's technology could one day create traces so durable that they outlive even our species. Signals, structures, or artifacts that might one day be discovered by future explorers, human or alien. Because in the vast emptiness of time, survival is one thing, but leaving a message is another. If humanity vanished tomorrow, what would we leave behind? The first days would be quiet, cities still standing, lights flickering out one by one as power grids fail. But over decades and centuries, nature would reclaim what we built. Concrete would crack, metal would rust, glass would shatter, our monuments would erode under wind and rain. Even the tallest skyscrapers would eventually crumble into unrecognizable piles. But not everything would vanish so quickly. Some of our creations could last astonishingly long. So long, in fact, that they might still be here millions of years after we're gone. Let's start with the obvious, stone structures. The pyramids of Giza have already endured for 4,500 years, surviving earthquakes, invasions, and the slow grind of time. With no humans around to destroy them, they could last hundreds of thousands of years before eroding completely. Our giant stone monuments, like Mount Rushmore or the statues of Easter Island, might also endure for vast stretches of time. But there's something even more interesting. Artifacts that don't look impressive, but are incredibly durable. For example, the Voyager 1 and 2 spacecraft, launched in 1977, are drifting beyond our solar system right now. Long after Earth has been reshaped by geology, those spacecraft will still be out there, silent messengers carrying golden records that explain who we were, just in case someone finds them. In deep space, with no atmosphere to erode them, they could last for billions of years. Another candidate, radio waves. Every day we beam out signals, TV broadcasts, radar pings, and data transmissions that leak into space. Most of these fade into background noise within a few light years. But in theory, a sufficiently advanced alien civilization with a massive receiver could still detect them centuries later. These signals are our accidental shouts into the void, a kind of ghostly fingerprint of our time here. Then there's geological traces, things we don't even mean to leave behind. Our mining operations, buried waste, and even the sudden spike of industrial chemicals in sediment layers might form a technofossil signature in Earth's rocks. Millions of years from now, future scientists, whether human or alien, could dig down and find a thin band in the rock that screams, "Something big happened here." If we really wanted to be remembered, we could intentionally build forever artifacts. Imagine an enormous, indestructible structure in Earth orbit made from materials resistant to erosion, micrometeorites, and radiation, or a set of probes buried deep beneath the moon's surface, each containing libraries of human knowledge, DNA samples, and a map of our solar system. Unlike Earth, the moon has no atmosphere, no weather, and almost no geological activity, so artifacts there could survive virtually unchanged for billions of years. Of course, this raises an unsettling thought. What if other civilizations have already done this? What if there are alien monuments, probes, or signals out there, quietly waiting to be found, but we haven't noticed yet? This is the heart of one Fermi paradox solution, called the archaeological hypothesis. Maybe civilizations do exist, but we're finding their ruins instead of meeting them face to face. It's the cosmic equivalent of walking through a forest and only seeing ancient, moss-covered campsites, evidence of travelers who came long ago but are now gone. And here's the twist. If this is true, it means there's a clock ticking for us too. Someday, humans may no longer be here, but our artifacts could be. The real question becomes, will they tell a story of a species that burned brightly and disappeared, or of one that endured long enough to meet others in the deep night of space? In the next section, we'll explore the strange idea that maybe the reason we don't see alien civilizations is that they've all moved somewhere else, places far more stable than planets, and perhaps far harder for us to detect. What if we've been searching in the wrong places all along? When we imagine alien civilizations, we picture planets like Earth, lush, stable, and full of life. But from a cosmic engineering perspective, planets are actually not the best place to live forever. They have earthquakes, volcanoes, climate change, and asteroid impacts. Stars eventually swell and die, destroying everything nearby. Even a perfectly managed planet is temporary on astronomical timescales. Some scientists and futurists have suggested that advanced civilizations might eventually abandon their homeworlds entirely. Instead, they could build artificial habitats, massive structures in space designed to be stable for millions or even billions of years. One of the most famous ideas is the O'Neill cylinder, a gigantic rotating tube in space that uses centrifugal force to simulate gravity. Inside, you could have forests, rivers, and entire cities, all protected by layers of shielding against radiation. Unlike planets, these habitats could be moved anywhere. Near a star for warmth, far from one for cooling, or even drifting between stars. Then there's the even more ambitious concept of Dyson spheres. Vast swarms of satellites or structures completely surrounding a star to capture nearly all its energy output. Freeman Dyson proposed this idea in 1960 as a way an advanced civilization could power its entire society. If such a thing existed, it wouldn't look like a normal star to us. It would glow faintly in infrared light, its visible light blocked by the megastructure. But here's where the mystery deepens. We have looked for strange infrared signatures in our galaxy using telescopes like WISE and Spitzer, and so far, we've found nothing that's obviously a Dyson sphere, which means either they're incredibly rare or advanced civilizations hide their energy use, or maybe they've gone somewhere else entirely. That somewhere else could be the edges of a star's habitable zone, or even the outer edges of the galaxy. Some theorists believe civilizations may migrate outward over time, toward cooler, dimmer regions where stars burn slower and last much longer. The smaller a star is, the longer it lives. Red dwarfs, for example, can burn for trillions of years, thousands of times longer than our sun. If survival is the goal, these dim stars are the ultimate real estate. And here's the problem for us. From Earth, these stars are hard to study in detail. If a civilization was living out there, they'd be faint, cold, and quiet. They might even deliberately use minimal energy, blending into the natural background to avoid drawing attention, something called the stealth civilization hypothesis. It's also possible that some have gone even further, beyond normal space entirely. If a civilization mastered exotic physics, they might live in artificial universes of their own making, or in energy-efficient simulations, barely interacting with the physical galaxy at all. To us, they'd be invisible, silent, absent. And we'd be left wondering why the stars are so empty, not realizing the galaxy might actually be full. We just can't see the ones who have moved on. In the next section, we'll explore a stranger possibility. Maybe we do see signs of alien civilizations all the time, but we dismiss them as natural phenomena because we don't know how to recognize them. What if the biggest clue has been in front of us all along, and we just didn't recognize it? When astronomers scan the sky, they're not just looking at pretty star fields. They're analyzing light, its color, brightness, and patterns to figure out what objects are made of and how they behave. But here's the catch. Our instruments and our thinking are tuned to detect natural processes. We assume that if something looks like a star, it is a star. If something flickers, we think of dust clouds, gas jets, or gravitational lensing, not alien engineering. This bias means that if a civilization built something that didn't look like a Hollywood-style spaceship, but instead like a strange star or a peculiar asteroid, we might have already catalogued it as just another natural object. One famous example of this is Tabby's star, officially KIC 8462852. In 2015, astronomers noticed its brightness was dipping in bizarre, irregular ways, up to 22% at times, far too much for a planet passing in front of it. Some scientists speculated that perhaps a partial Dyson swarm could explain it. The media loved the idea. But after years of study, most researchers now think it's probably clouds of dust or comet fragments. Still, the mystery isn't fully solved. Then there's Oumuamua, the interstellar object that zipped through our solar system in 2017. It came from outside our star system, had an odd, elongated shape, and didn't move exactly like a normal rock. Its path changed slightly, as if something was pushing it, yet no obvious comet tail was visible. Harvard astronomer Avi Loeb famously suggested it might be an alien probe or a piece of alien technology. Most of the scientific community disagreed, leaning toward unusual but natural explanations. Still, the case remains intriguing, because it showed how quick we are to default to nature did it, instead of entertaining the possibility of someone made it. This brings us to an uncomfortable truth. If alien technology is more advanced than we can imagine, we might not even have the vocabulary to describe it. Imagine trying to explain a smartphone to someone from the year 1000 CE. They might call it a magic stone. Likewise, if we see alien engineering in space, it might appear as something mundane, like an oddly warm gas cloud or a star flickering in just the wrong way. Physicist Arthur C. Clarke once said, "Any sufficiently advanced technology is indistinguishable from magic." But here's the twist. It's also indistinguishable from nature if you don't know what to look for. This is why some researchers have proposed a new approach called artifact SETI, searching not for radio signals, but for strange astronomical phenomena that don't quite fit the natural models. The challenge is that the universe is messy. Stars flare, black holes burp, nebulae shimmer in unpredictable ways. Nature is already full of weird. So, how do we tell the difference between the truly alien and the merely unusual? The answer might lie in patterns, repeated, unnatural regularities in light or motion that can't be explained by physics alone. But finding such patterns is hard, because space is vast and data is overwhelming. Even with AI scanning billions of stars, our assumptions still shape what the AI is told to look for. And here's the chilling possibility. If alien civilizations want to hide, they could design their technology to mimic nature perfectly, disguising themselves as stars, comets, or even entire galaxies. They wouldn't need to cloak themselves with sci-fi invisibility fields. They just need to blend into the cosmic background noise. In the next section, we'll go deeper into this camouflage idea and explore the mind-bending possibility that the aliens could already be here. Not in spaceships, but in forms and places we'd never think to check. If you wanted to hide in the universe, where would you go? Most of us imagine advanced aliens building massive space stations, living on huge metal ships, or colonizing planets. But that's a very human way of thinking. Why would they choose planets at all? Planets have storms, gravity wells, and unpredictable geology. For a civilization millions of years older than us, a planet might seem inconvenient. Instead, they could choose deep space, drifting between stars where hardly anyone looks. Or they could live inside hollowed-out asteroids, their heat signatures matching the surrounding rock. From a distance, our telescopes would just see another boring space rock. In fact, our catalogues of near-Earth asteroids already contain thousands of objects we've barely examined. Some have odd tumbling motions or unusual reflectivity, but we rarely follow up unless they pose a threat to Earth. Here's the unsettling part. If a civilization wanted to visit us without being noticed, they wouldn't have to land a giant ship on the White House lawn. They could park a disguised craft in the asteroid belt or on the dark side of the moon, watching and listening. The energy output could be so faint, just enough to run sensors, that it would blend in with background cosmic radiation. And if they were even more cautious, they could hide in plain sight by mimicking natural phenomena. Think about pulsars, rapidly spinning neutron stars that send out beams of radio waves in precise intervals. We discovered them in 1967, and at first called them LGM for Little Green Men, because their signals were so regular. Turned out they were natural. But what if a civilization learned to imitate that kind of regularity, to transmit information without us noticing? Then there's the possibility of molecular camouflage. Life on Earth is carbon-based, so we tend to search for other carbon-based life. But alien life, or even alien machines, could be made from entirely different chemistry. Imagine an organism made of plasma, living inside a star. We'd never recognize it as alive, because our definition of life is built around cells, DNA, and liquid water. This raises a haunting thought. What if the galaxy is teeming with civilizations, but all of them are camouflaged so well that from our perspective, they are nothing but rocks, clouds, or even starlight itself? We could be walking through a cosmic forest full of hidden creatures while believing we're alone in an empty field. Some scientists believe camouflage might not be a choice, but a survival strategy. If the universe is competitive, if some civilizations prey on others, then blending in could be the difference between survival and extinction. In that case, it wouldn't just be that aliens can hide. It would be that every advanced civilization must hide. This leads to a disturbing extension of the Fermi paradox called the dark forest hypothesis. The idea is that the universe is like a dark forest full of hunters. Every civilization is silent, trying not to be noticed, because announcing yourself could attract a predator. In that kind of galaxy, calling out with radio signals, like we've been doing for a century, might be like lighting a campfire at night in the middle of a dangerous jungle. You never know who might be watching. If that's true, then our failure to see aliens isn't because they don't exist. It's because they're deliberately staying invisible, and maybe, so should we. In the next section, we'll explore this cosmic silence idea and why our eagerness to send signals into space could either start humanity's greatest conversation or its final one. Silence. It's something we usually associate with peace. Quiet mornings, empty rooms, calm skies. But in the search for life beyond Earth, silence can feel unnerving. For over 60 years, we've been listening. Giant radio dishes like the ones at Arecibo before its collapse, or the Green Bank Observatory, have scanned the skies for unusual patterns, signals that nature wouldn't produce on its own. The logic is simple. If we can use radio to communicate across continents, surely advanced civilizations could use it to communicate across stars. And yet, nothing. No confirmed alien messages. Just static, natural background noise, and the occasional strange blip that vanishes before we can check it again. One of the most famous was the WOW signal, detected in 1977 by astronomer Jerry Ayman. It was a strong, narrowband signal from deep space that lasted 72 seconds. It didn't match any known natural source, and it came from a patch of sky with no nearby stars that we could identify. Ayman circled it on the printout and wrote "Wow" in the margin. But despite decades of follow-up, we've never heard it again. The mystery isn't just that we hear nothing, it's that the universe itself seems to cooperate with the silence. Signals fade quickly over interstellar distances. Space is vast, and our listening windows are short, sometimes just seconds for a given part of the sky. We're like someone standing on a beach, trying to hear voices across an ocean, while only holding a seashell to our ear. But some scientists think the silence might be intentional. This is where the dark forest hypothesis we touched on earlier comes into sharper focus. Imagine every civilization is both a hunter and prey. If you reveal your position, you risk being destroyed. So the safest option? Never speak, never send, just listen and stay hidden. This has led to a debate in the scientific community. Should we stop broadcasting our existence? Right now, Earth is anything but quiet. We've been leaking signals into space since the early 20th century. Radio shows, TV broadcasts, military radar, all of it travels outward at the speed of light, forming an expanding bubble about 200 light years across. Any civilization within that range with sensitive enough instruments could already know we're here. On top of that, some scientists have actively sent targeted messages. In 1974, the Arecibo Observatory beamed a message toward the globular star cluster M13, a picture encoded in binary, containing images of DNA, a human figure, and our solar system. More recently, projects like METI International have sent new signals to specific exoplanets. Critics warn that this might be reckless. Stephen Hawking himself cautioned that contacting advanced civilizations could be dangerous, pointing to Earth's own history, where encounters between cultures at vastly different technological levels often ended badly for the less advanced side. Supporters of messaging counter that it might not matter. If hostile civilizations exist and can find us, they probably already have. Staying silent now might be too late. This leaves humanity in a strange position. Do we keep calling into the darkness, hoping for a friend? Or do we stop, hoping that the darkness hasn't noticed us yet? One thing is clear. If the dark forest hypothesis is correct, the silence we hear might not be a sign of emptiness at all. It could be the sound of a galaxy holding its breath. In the next section, we'll explore the unsettling idea that alien civilizations might not just be silent, they might be actively watching us already. And if they are, what exactly could they be waiting for? The idea that someone, or something, could be watching us right now sounds like the opening line of a science fiction novel. But in the search for extraterrestrial life, it's a possibility scientists take seriously. Because if intelligent civilizations exist, they don't necessarily need to talk to us. They might just observe. Astronomers already know how to do this from great distances. Here on Earth, we've detected thousands of exoplanets, not by visiting them, but by watching their stars for tiny dips in brightness, caused when a planet passes in front of them. This is called the transit method, and it's sensitive enough to not only find planets, but to study their atmospheres. That means, theoretically, an alien astronomer on a distant world could be doing the same to Earth. If their telescopes were advanced enough, they might see our planet pass in front of the sun. They could measure the sunlight filtering through our atmosphere and detect oxygen, water vapor, and methane, 3 chemical clues that life exists here. From there, they might look closer. Imagine a network of probes scattered across the galaxy, tiny machines sent out millions of years ago by a long-gone civilization. They wouldn't need to be big. Something the size of a refrigerator could contain more computing power than we can imagine. They could drift silently, powered by starlight or tiny nuclear batteries, transmitting what they see back to their creators, or to no one at all, simply fulfilling their programming. This is the Bracewell probe hypothesis. The idea that alien civilizations might send autonomous probes instead of making direct contact. A single probe could sit in a planetary system for thousands of years, silently watching, collecting data, and waiting for signs of technological life. And here's where it gets unsettling. If such a probe were in our solar system, would we even notice? Space is huge, and most of it is empty. Even in our own cosmic backyard, small objects can go unseen for decades. In fact, astronomers have only recently begun systematically scanning for things like interstellar asteroids and comets, like Oumuamua, which zipped through our solar system in 2017. Oumuamua was likely a natural object, but it sparked huge debates because it was odd. It moved strangely. It had no visible tail like a comet, but it accelerated as if something was pushing it. Harvard astronomer Avi Loeb suggested, controversially, that it might be artificial, perhaps a fragment of alien technology or a discarded probe. Whether or not Oumuamua was anything unusual, it proved an important point. The solar system could easily contain visitors we haven't noticed yet. And what if those visitors are not here to harm us, but to study us, like scientists watching wildlife from a hidden camera? Some suggest that if we're being observed, the watchers might be waiting for us to reach a certain level of development before revealing themselves. A kind of cosmic quarantine, keeping us isolated until we're ready for contact. This is similar to the zoo hypothesis, which proposes that alien civilizations deliberately avoid interacting with us, just as zookeepers avoid directly interfering with animals in an enclosure. We might live inside a galactic preserve, free to develop at our own pace, while they watch from beyond the fence. The unsettling part? If that's true, then we are the only ones unaware of the arrangement. It means the silence in the galaxy is not because no one is there. It's because they're choosing not to answer. In the next section, we'll explore one more possibility, one that shifts the question entirely. Maybe we're not the latecomers to a living galaxy. Maybe we're the first. When we look up at the night sky, it's easy to imagine that life must be out there somewhere. After all, with billions of stars in the Milky Way alone and trillions of planets, surely someone else must have appeared before us. But what if no one has? This is the Firstborn hypothesis, the unsettling idea that humanity might be one of the earliest, if not the first, intelligent civilizations to arise in our galaxy. At first, that might sound like good news. If we're the first, it means the galaxy is wide open for exploration. There are no ancient empires to compete with, no alien wars to fear, no galactic rules to follow. We would have the privilege and the responsibility of shaping the first chapter of intelligent life in the cosmos. But it also means something far heavier. We would be alone, not because others don't want to talk to us, but because there's simply no one there. To understand why this could be the case, scientists look at the history of the universe. The cosmos is 13.8 billion years old, but for much of that time, the conditions for complex life weren't ideal. In the early universe, there were few heavy elements, things like carbon, oxygen, and iron. Those elements are forged inside stars and spread through space when stars explode. It took billions of years for enough of them to accumulate to build rocky planets and living chemistry. If that's true, then maybe intelligent life could only have emerged in the last few billion years, and we just happened to appear early in the queue. And if we're early, then the future could be mind-boggling. The galaxy could one day be filled with civilizations that evolved long after us. In 100 million years, there might be millions of alien cultures, but they would all trace their awareness of the wider galaxy back to us. We wouldn't just be explorers, we'd be the elders. There's a strange kind of loneliness in that thought. Right now, if we are first, the responsibility is enormous. Every choice we make, every signal we send, every footprint we leave beyond Earth would be part of the origin story for all future intelligent life. It also reframes the Fermi paradox. The question, where is everybody, becomes, who will we become before everybody else gets here? But there's a quiet warning in this idea too. If we are first, then we are also the first species to face the challenges of space travel, resource limits, and self-destruction. And if we fail, if we don't survive long enough to meet the others, then the galaxy might remain silent for eons more. So maybe the real message of the Firstborn hypothesis is this: survival isn't just about us. It's about holding the door open for every civilization yet to come. In the final section, we'll bring everything together: the silence, the possibilities, and what it might all mean for our place in the universe. And so, after exploring all these possibilities, the hidden civilizations, the dangerous signals, the ancient ruins that may never have been, and the idea that we might be the first, one truth stands out. The silence of the universe is not just a scientific puzzle, it is a mirror. When we peer into that vast, quiet darkness, we are really looking at ourselves. The Fermi paradox isn't just about where everyone is. It's about who we are, what we value, and how we choose to move forward in a cosmos that may or may not be listening. If the galaxy is teeming with life, then every action we take now could shape our first contact. We could be remembered as the reckless species that shouted into the void without caution, or the thoughtful explorers who stepped carefully, prepared to meet the unknown with wisdom. If the galaxy is empty, if we truly are alone, then our responsibility is even greater. We would be the sole keepers of consciousness in a vast ocean of unthinking matter and energy. Every dream we dream, every work of art, every act of kindness would be the rarest thing in existence. This perspective makes our everyday problems seem both tiny and enormous at the same time. Tiny, because arguments and divisions here on Earth are nothing compared to the scale of the universe. Enormous, because the way we treat one another could determine whether we make it long enough to see what's out there. In a way, the Fermi paradox is a story about time. The universe has existed for billions of years, and it will exist for billions more. We happen to be here now, in this fleeting window of cosmic history, with a chance to become something more than just another vanished species. So maybe the real answer to where is everybody is they're waiting for us. Waiting for us to grow, to explore, to learn, and to survive long enough to join the greater conversation, whether that conversation is with others or simply with the future. The night sky will keep its secrets for now, but one day, perhaps far from today, the silence will end. A signal will arrive, or a ship will appear, or maybe, just maybe, we'll be the ones to break the silence first. Until then, we live in the greatest mystery of all, a mystery written across the stars, calling us to listen, to wonder, and to keep looking up. Now, as we step back from the dizzying possibilities of the Fermi paradox, let's slow everything down. Imagine yourself lying somewhere quiet, perhaps in your backyard on a warm night, or out in the countryside far from the noise of cities. Above you, the stars stretch endlessly, a soft scattering of silver on black velvet. You take a slow breath in and out. The universe feels impossibly big, but it's also calm. There's no rush to solve its mysteries tonight. Somewhere out there, perhaps, other minds might be wondering the same things you are. Or maybe the silence means it's just us. Either way, this moment is yours, safe, still, and peaceful. You think about the billions of years behind us, and the billions ahead. Our human story is just a blink in cosmic time, yet in this blink, we have built cities, told stories, fallen in love, and reached out toward the stars. That is no small thing. The night sky is quiet, but that doesn't mean it's empty. It's full of potential, waiting for us to keep looking, keep learning, and keep caring for the little blue world we call home. As you breathe slowly again, you feel a sense of connection, not just to the earth beneath you, but to everything. The atoms in your body were once inside ancient stars. The light you see tonight began its journey long before you were born. You are part of the universe, and the universe is part of you. The mystery will still be there tomorrow. For now, Let it be a gentle reminder that you are living inside an extraordinary, fleeting moment in the history of everything. Close your eyes, rest. The stars will keep watch, will keep